This is a Bosch 711 fuel injection pump test bench. It has a continuous injection output measuring system. Instead of collecting the delivered fuel in glass calibration tubes, this bench has a visual display unit, or a VDU screen, which continuously shows the quantity of fuel delivered from the fuel injection pump being tested. The test bench flywheel, with its drive shaft, inner protective covering, is connected to the injection pump through its drive coupling. The injection pump shown mounted on the test bench is a P-series Bosch Inline fuel injection pump with a mechanical governor. On the end of the governor is a manifold pressure sensing unit, which is used in conjunction with the engine's turbocharger. This injection pump is from a Mercedes-Benz diesel engine. This is the test specifications plan for this particular model injection pump. It lists the essential test requirements needed to accurately test and adjust this injection pump and governor. It specifies the dimensions of the test lines and test injector nozzles needed for standardised testing. The first part of testing this fuel injection pump is to check the pump pre-stroke. The pump pre-stroke is the amount of plunger travel from the bottom of its stroke up to spill cutoff. The table shows the recommended fuel deliveries at different rotational speeds. The second part of the test plan shows the specifications for the governor and torque control settings. To check the pre-stroke, the test bench is switched on, and when the flow from the test injector is observed, the fuel pressure is increased to obtain an output of 25 bar. Zero the dial gauge on the pre-stroke measuring tool, which has been mounted on the pump. This marks the bottom of the pump plunger stroke for this cylinder. Turn the flywheel, which is connected to the pump, in the direction of rotation, watching the fuel flow from the test injector until it decreases to a slow drip. This is the point of spill cutoff, or the commencement of injection for this cylinder. The reading on the dial gauge indicates the amount of plunger pre-stroke. In this case, it reads 4.0 millimeters, which is within the tolerance shown on the test specifications. If the reading is outside recommended specifications, adjustment is achieved by adding or removing different thickness shims under the element flange. At this point, a timing mark is scribed on the pump coupling to align with the timing pointer on the front of the pump. The test bench indicator, which acts as a reference point, is moved to line up with a convenient degree line on the flywheel. With the pre-stroke indicator tool and dial gauge removed, the flywheel is then turned in the direction of rotation until the point of spill cutoff is obtained for the next cylinder in firing order. This should be exactly 45 degrees from the reading on the last cylinder. It would be usual to proceed and check all cylinders in firing order. Run the pump at the specified rotational speed, and with the control rod travel set at the recommended distance as shown on the dial gauge located on the end of the pump, observe the VDU, which continuously shows the fuel delivered for 1,000 shots from each element or cylinder. The two horizontal lines across these bar graphs indicate the upper and lower fuel output limits. In this case, it indicates that number 1 element is delivering insufficient fuel. The output of number 1 pumping element is increased by partially rotating the element housing after loosening the clamp nuts. The outputs from all elements are now within limits.